Assalamualaikum and good morning. My name is Siti Nurul Izzah Binti Kamaruddin, metric number MH20063. Today, I would like to explain about external combustion engine. External combustion engine are the most common form of external heat engines. It is because of their use in power plants. In external combustion engine, is An external combustion engine is unique from other external heat engines because it requires a fuel to undergo combustion to create the heat that is used for work. Okay, next is what is the external combustion engine? Okay, a combustion engine is a complex machine that is burned fuel to produce thermal energy and then use the thermal energy to do works. There are two types of combustion engine, which is external and internal combustion engine. A steam engine is an external combustion engine. Okay. External combustion engines are no longer used in transportation as mobile designs are not efficient enough. But they are continue to be used in power plants. For example, natural gas power plants boil water into steam to turn a turbine, creating electricity. The external combustion design means that the natural gas does not come in direct contact with the water, and the engine still use the immense amount of energy emitted to do useful work. A coal-fired power plant works in much the same way, where coal is taken into the plants from the mine and burned in a boiler. Pipes send water into the boiler and the burning coal boil the water, creating steam which turn a turbine and create electricity. How it's work. An external combustion engine burns fuel externally or outside the engine. The burning fuel releases thermal energy which is used to heat water and change it to steam. The pressure of the steam moves a piston back and forth inside a cylinder. The kinetic energy of the moving piston can use to turn a vehicle's wheels, a turbine, or other mechanical device. This is the external combustion engine, which is you can see it to be more understand. Okay, first is this is exhaust steam, which is in the blue colors, and the high pressure steam in the red color. Okay, first the steam enter the cylinder from the left and push against the piston, forcing the piston to the right, which is the steam enter the cylinder and from the left side it push against the piston to the right side. Okay, next is the steam enter the cylinder from the right side and push against the piston, forcing the piston to the left. This is the piston. Okay. Third is as the piston move back and forth, the piston rod attached to the move back and forth as well. Lastly, the kinetic energy of the moving piston rod is used to turn the turbine or other mechanical device. This is the piston that will be moving the turbine or other mechanical device. Next is the first example is steam engine. A steam engine is a heat engine that performs mechanical work using steam as its working fluid. The steam engine uses the force produced by steam pressure to push the piston back and forth inside the cylinder. This pushing force can be transformed by connecting rod and flywheel into rotational force for work. The term steam engine is generally applied only to reciprocating engine as just described, not to the steam turbine. Steam engines are external combustion engine, where the work fluid is separate from the combustion products. In the engine, steam is obtained with the help of heat obtained by burning coal. The steam then sent to an engine where its pressure energy get converted into work. The engine that was used at that time was its reciprocating type. This kind of reciprocating external combustion engine are not in use now. They have been totally replaced by internal combustion engine. The reason of the replacement was their big size and inefficiency. Also, they require a lot of maintenance. The next example is a steam turbine. A steam turbine is an external combustion engine which expands steam and converts it into energy for a useful work. Since the steam is produced somewhere outside the turbine, which is an engine, it is known as external combustion engine. In most of the power plants in the world, steam turbines are used to generate electricity. The reason of their popularity is that since they are external combustion engine, so they have nothing to do with the type of fuel which is used to convert water into steam. All the steam turbines need is good quality steam. The variety of fuel which can be used to generate steam in steam turbine is very large. It can be a coal, wood, grass, straw, liquid, or gaseous fuel.
The Stirling engine is recognized by the Department of Energy as a promising alternative to the internal combustion engine. An external combustion engine, the Stirling burns any fuel, creating heat for the cylinder. The heat itself powers the engine. Any fuel can be used, liquid, solid, or gas. The Stirling even operates on heat from nuclear and solar energy. Combustion is continuous and complete, quiet and clean. Ongoing research in aeronautical and automotive engines at the NASA Lewis Research Center in Cleveland, Ohio, indicates the Stirling may be the engine of the future. Feasibility studies by manufacturers indicate the technology to produce Stirling engines commercially exists today. Value engineering studies have shown the Stirling can be manufactured in low production volumes at a competitive cost. The engine can be built to provide power for both propulsion and stationary applications. A Stirling engine developed by Mechanical Technology Incorporated for NASA Lewis Research Center and the Department of Energy has been evaluated by a NASA Technology Utilization Program under actual driving conditions. The Stirling engine was installed in an Air Force van. The van's original 150 horsepower diesel engine was replaced by a 75 horsepower Stirling and assigned actual duty service at Langley Air Force Base in Virginia. Air Force operators drove the van throughout the test, serving 10 to 15 aircraft on a flight line, driving from base to aircraft, moving about the field in and around aircraft, stop and go, hauling personnel and equipment. Performance was monitored by special equipment mounted in the van. Engine speed, vehicle speed, and miles accumulated were recorded daily. During this Air Force mission, 3 different fuels were used: unleaded gasoline, JP4 aircraft fuel, and diesel fuel. The van functioned normally during the 1-year evaluation period on whatever fuel was available. The Stirling's high torque capability at low speeds enabled towing of all heavy support equipment. After 1,400 hours and 7,000 miles, results showed improved fuel economy. A second vehicle, a standard Air Force truck, was also evaluated. The truck's original 95 horsepower internal combustion engine was replaced by a 75 horsepower Stirling engine. Tests were conducted over a 1-year period for 1,000 hours and 19,000 miles of open highway and city streets, on rough and rural roads, and in normal traffic in a variety of environments. In moderate climate, the Norfolk, Virginia area, an expediter mission at Langley Air Force Base. Hot, moist sea air environment, a general transportation assignment at Eglin Air Force Base, Florida. Hot, dry environment, base taxi service at Randolph Air Force Base, Texas. In the north, a base supply mission at Offutt Air Force Base, Nebraska. In addition, the truck was driven from Texas to Washington, D.C., a distance of 1,600 miles. The entire trip averaged over 50 miles per hour. The Stirling consistently delivered more miles per gallon. Current engines are a major contributor to the severe atmospheric pollution in our cities today. Exhaust emissions were evaluated, and the Stirling engine met federal emission standards. No catalytic converter or particulate trap was needed. The exhaust is cool and clean. The Stirling engine can help reduce these pollutants to meet even the most stringent California standards. Also, several maintenance requirements were eliminated, with only 1 spark plug to start combustion, no carburetor, no catalytic converter, and no muffler. Because the engine oil is not exposed to combustion products, it stayed clean and uncontaminated throughout the test, eliminating the oil changes. The Stirling engine offers increased fuel economy, multi-fuel flexibility, and reduced life cycle costs. Its economy and efficiency of operation are being demonstrated. The Stirling engine appears ready for market. NASA's Technical Utilization Division continues to work with U.S. industry, providing data to manufacturers and end users, answering the questions on Stirling technology. And the technology is available now to build the power plant of the future today. Power for America, on the land and in space. The Stirling engine, an alternative power plant of the future.
The last example is Chandu reactor. Okay, Chandu reactor is a type of nuclear reactor which was developed in Canada and is currently used in nuclear power plants for electrical generation in various countries around the world. Chandu stands for Canada, uh, deuterium, uranium, which reflect the key role of deuterium or heavy water, which act as the reactor's neutron moderator, a unique trait of the Chandu. The reactors are also different from the other reactors because they are designed to utilize natural uranium as a fuel. The use of this reactor in power plant is Canada provide the country with around 50% of its total electricity, with 19 currently in operation. 12 Chandu reactors are also used in China, South Korea, Romania, India, Pakistan, and Argentina. There are many advantages of external combustion engine, which is almost any kind of fuel that is available can be used. Next is since power is not generated due to detonations of fuel, hence very less noise is generated. The third one is engine emissions are also very low. And the last one is very economical for huge power generation. Okay, next is the disadvantages of external combustion engine. Okay, the first one is not suitable for low load requirement. Second one is the leakage of working fluid. The third one is the lubricant consumption. The fourth one is the size of engine is relatively big. And the last one is overall working temperature is high, so great care and special building material are required. There are many types and application of external combustion engine. The first thing is a steam engine, which is we can see a locomotive and marine. For the second one is Stirling engine, which is experimental space vehicle. The third one is steam turbine, which is power and large marine. And the last one is closed cycle gas turbine, which is power and marine.
In this video, I explain you difference between IC engine means internal combustion engine and EC engine means external combustion engines in the detail. Here in this figure you see this is the internal combustion engine and this is the external. So why it's called internal and external combustion engine, that I also discuss in this video. So on the left side I written this point of the IC engine means internal combustion engine, and on the right side it is the EC engine, that is means external combustion engine. So from its name we can understand that the combustion is takes place inside the cylinder, then it is known as the IC engine. So here I written this point, combustion of the fuel takes place inside the cylinder, means name is suggested internal means inside and external means outside the cylinder, means it is the depend on the process of combustion. If combustion is takes place inside the cylinder, then it is known as the IC engine. and combustion of the fuel takes place outside the cylinder, then it is known as the external combustion engine, or in short it is known as the EC engines. So here I show you the figure of IC engine, means internal combustion engine. So in a internal combustion engine we use the fuel like a petrol, diesel or gas. Okay, and the petrol is supplied with this air. So here the combustion of the fuel takes place, and due to this combustion high pressure is created, and these high pressure gases is applied the force on this piston, and piston is rotate this shaft, and shaft is produce some work done. So mechanical power is produced by using the IC engines. The hot gases are subsequently expand to develop the mechanical power, means the combustion gases expand. Okay, then we produce some mechanical power on the shafts, and it is generally used in our bike and car and different transportation devices because its size is compact compared to the external engines. So external engine is right now not is used in any automobiles vehicles. In earlier case, the IC engine is used in the locomotive trains. So in a 40 to 50 years back, the steam engine is used into the railway to run the train. But right now in train is run by using this electric engine, that is by using the electric power. So in a train, here you see in this figure, the combustion takes place outside the cylinder. So where is the cylinder? This is the cylinder and piston arrangement. Okay, so this heat energy of this combustion gas is supplied to the water, and water is converted into the steam, and steam is supplied as a fuel inside the cylinder. So combustion takes place outside the cylinder. This is a cylinder, and combustion takes place here in the furnace, and it is known as the external engine. So external combustion engines are not suitable for mobile plants, means for a transportation purpose, because of these have a heavy and bulky in the size, and the IC engine are smaller in size. That's why it is used in our transportation vehicles and different automobiles vehicles. Now before moving ahead, I request to like the video and subscribe the channel for watching the more video related to mechanical engineering. You also visit the playlist to watch the various subjects of mechanical engineering like the elements of mechanical engineering, basic mechanical engineering, IC engines, refrigeration, air conditioning, fluid. So lots of subject is available, so you visit that. Now in a IC engine, temperature and pressure is higher inside the cylinder. In a EC engine, temperatures and pressure is lower compared to the IC engine. Now in an internal combustion engine, the working fuel may be petrol, diesels or various type of the gases. That is already we use in our bike and car. That is petrol, diesels and gases are used. In an external combustion engine, working fuel are steam. Now the steam is produced by using the burning of coal, wood or any another waste. Okay, so main fuel energy used is the coal or a wood, and this heat energy of the coal and wood is supplied to the water, and water is converted in steam, and this steam is supplied inside the cylinder. That's why here written the working fluid is a steam. It required a less space, and external combustion engines required a larger space, that we already seen in this image. So in our bike or a car, the engine require a small space, but in earlier case, that is a steam and external combustion engine is used in a railway or in a trains to run it. Okay, now external combustion engine right now used in a gas power plant and a steam power plants. Capital cost is relatively low for a internal combustion engine, and for external combustion engine, capital cost is relatively high. Now IC engine, starting of the engine is easy and quick. So as you know that you can start your bike or a car by just moving the key or by giving the accelerator, so it is easily start. So we are not require any more times. But in external combustion engine, it required a more time, because the steam is generated by burning of the coal or wood. So it's require lots of time to start it, because burning of the coal and woods are take the much time. So its starting of the engine is required time. Thermal efficiency is high because the combustion takes place inside the engine. So there is a no loss of thermal energy, means less loss of thermal energy compared to the external engines. In an external engine, thermal efficiency is low because the combustion takes place in a different place. Then after this, heat energy is transferred inside the cylinder, so losses are increased due to the transportation of the heat energy. So thermal efficiency is lower for external combustion engine. Now power developed per unit weight of this engine is high, means power developed by the internal combustion engine is higher compared to the external combustion engines. In external combustion engine, power developed per unit weight of this engine is low. And the last point is fluid cost is relatively high. So which fuel is used in a internal combustion engine? That is the petrol, diesels and gases. So they are costlier. And the fuel use or the fuel cost is relatively low in external combustion engine. So which fuel is used in a external combustion engine? It is a coal, it is a wood or some waste energy is used. So cost of the coal and woods are comparatively lower than the petrol, diesels that is used in internal combustion engines. So thank you for watching this video. If you learned, then like the video, subscribe the channels and share with your friend.
To summarize, a combustion engine is a complex machine that burns fuel to produce thermal energy and then use the thermal energy to do works. Okay, the next one is an external combustion engine burns fuel externally or outside the engine. And lastly, an external combustion engine burns fuel to heat water and produce steam. The steam is under pressure and is used to push a piston back and forth inside a cylinder. As the piston moves back and forth, it moves a piston rod which can do a work. Okay, lastly, thank you for lending your time to listen to my explanation about external combustion engine. Hope you can understand and not getting bored with my speech. Thank you very much.